So great. Let's delve into the development playground by starting to talk technical. Our first technical session would be talking about Sophia, a better smart contract programming language, and it will be anchored by Goodness Ezeokafor. Sorry, I don't know if I'm sure I didn't pronounce that properly. Goodness, please forgive me. Goodness is a web and blockchain developer who is the CEO of Elesarr, a decentralized crowdfunding platform. With Goodness, you won't just learn the easy way to write Sophia Smart Contracts, you will also know why Sophia is better. Goodness, welcome, and you can have the floor now.
Yeah, good evening, everyone. I don't know, can you guys see my screen? Okay, yeah.
Yes, we can see your screen.
Okay. Okay, hello, my name is Goodness Ezeokafor. Yeah, Debbie, you tried. I want to appreciate Jet and the host for inviting me to speak. It's really humbling. And so I'll be taking you guys on Sophia Smart. Yeah, I'll be taking you guys on Sophia Smart Contract. And okay, so Sophia was developed by the team at ækiti. It's this official smart contract language for the ækiti blockchain. And if you want to know more about ækiti, you can go to their website on aekiti.com. So first of all, Sophia smart contract it's a language that it used to build smart contracts on the ækiti blockchain, and it's basic program or transaction which is intended to automatically control or document legal relevant events and actions in terms of contract or an agreement. Well, but simply what smart contract means, it's basically or that means it helps you things like properties, money and all that. So if you have not done any cryptocurrency transaction on the blockchain, whether Ethereum, ækiti, or like what Jet did with Superhero, well, all those stuffs are governed or made possible through smart contracts. And basically what a smart contract, right, is basically it's basically the same concept with what a contract is. So a contract is like on the blockchain, it's more automated and self-executing. I mean, in the sense that okay, you just need a certain conditions to be met between one or between two people, and when that certain condition is met, it will perform the transaction. So if you go, if you use your AE wallet to transfer, let's say I have a Superhero wallet now, and I transfer some AE tokens to Jet, then through smart contract. So if the smart contract will check, okay, whether I have that amount in my wallet, or if whether I'm doing it the right way, and it just performs that transaction. Major advantage of a smart contract, you don't need a middleman or a third party. So usually transactions are made. Usually when we transact, let's say in Nigeria, we have banks. We transfer money from our bank to that, and then there's certain fees and all that. But with the blockchain, with smart contract, I can transfer a certain amount of cryptocurrency, right, to another person directly without any third party and or a middleman. So the benefits of smart contract, well, I've mentioned if you autonomy, you don't need a middleman, and trust, and also it's safe, and it's more accurate. So using smart contract, you can reduce human error to let's say 90 to 95% sorry. So the manual ways of doing transaction banks and using papers and all that, with smart contract we can automate all that and reduce. So basically that's what smart contracts is. Okay, so building Attenti smart contract by far, it's one of the best I've seen so far, and it's the code structure and the layout is quite easy for beginners to easily start writing smart contract in the Attenti blockchain. And I think one of the advantages that and these speed channels are built natively into Attenti, so you can really use that. It's not like that on Ethereum. I think you need some side chains and all that. But with Attenti is built native into the blockchain, to the Attenti blockchain ecosystem. So those are one of the advantage of Sophia, and it's quite easier than let's say Solidity or EOS and other smart contract language. And coding smart contract on Attenti, well, they have a cool website or a cool web platform called studio.aps.com. And you can start writing smart contract on Attenti using this particular web-based platform. Okay, so this studio, AEStudio, was developed by the Attenti team, and it's very robust. I've built quite some amazing apps with this platform, and if you compare it to Remix ID too, I think it's quite better. The error messages and the different tools are here. So this basically is the text editor. This is basically the text editor where you can write codes. You can create a new file and start on the giveaway, but you start writing your smart contract in a file. And after you finish writing your smart contract, you can go here and basically you can connect your GitHub. You can change the account. You can use a different account. You can also choose the particular amount, your gas price. So to really understand how to write smart contracts, you need to understand, okay, what's a blockchain? And I basically, when developing, blockchain simply means three things. It's a large computer connect and that other computers are kind of connected to it, and it's also a large network, and it's also a decentralized database. So there was an incident that happened yesterday on Twitter where the accounts of different popular important figures like Jeff Bezos, Elon Musk, and Bill Gates, the accounts were hacked, and some hackers carried out some scams on their different Twitter accounts. Well, you can do something, and if you see the explanation Twitter gave, and apparently they had kind of like I think kind of like a control, something like that, where you can tweet for, you can enter into another person's account and make a tweet, and that's what the hacker basically did, got access to that. And why they could do that, because Twitter basically operates, it's basically centralized. There's a particular server that controls everything, but on the blockchain, everything is decentralized on the blockchain. There's no a central figure or something like that. So if Twitter was built on the blockchain, also an Attenti blockchain, something like that would happen. Or you can't hear something like that happening on SuperheroLeague or other, because it's more secure and it's more decentralized. So you can't basically go to a particular place and control that with. You can't basically do that on Super League Hero and all that. So that's the benefit of the blockchain, and it's quite faster too. So let me get straight to Sophia. So that's done the explanation. So what we'll be building today, I'll show you how to build a to-do list application. And basically, what a to-do list is it's kind of like an application where you can manage your tax, and you can check whether your tax is you leave for what we'll be working on today, and it's quite easy to do something like that on ækiti. So I think Google has something like Google Keep and to do list, where it's kind of like it kind of works the same way. So you just basically list the tasks you want to accomplish for a particular day, and and tick whether it has been completed or not. Okay, so to start coding on this using Sophia. They have their set of syntax. Okay, it's basically means that whatever that you're trying, it basically initializes your smart contracts. Trees. But the contract you do will work that we're going to create kind of like an object. We're going to model out it to do. Now, I'm going to do that. Basically, it to do has basically the task, which I'm going to call to do, and it has we want to also store who created it to do. So I'll give it a creator.
Goodness, sorry, we can't see your screen again.
Yeah. Wow. Okay.
Please reshare.
Okay. Can you see it now?
Yes, we can.
Okay. Cool. Okay. So good. So basically, what a to-do list is, a to-do application is basically an application where you manage your tasks. Tick whether it's being completed and all that. And the first thing we're going to do is we're going to model that to-do list. The particular date the task was created. So I'll call this created to, and also check if it's completed. Now, to model out this structure, basically, we're going to use the record type in ækiti. So I'll create a record, call it to-do list, and I will put curly braces here. I will set an ID of int.
Goodness, we can't see your screen again.
Wow. Okay. You guys can see it, right? Yeah.
Yes, we can.
I don't know why it keeps turning off. Okay. I hope it doesn't turn off again. Okay. Created and completed. Okay, So cool. Okay, so when writing smart contract, there's a particular pattern. There's particular pattern when writing smart contract on Eternity. First of all, you want to give space after creating your contract, defining your contract, and you can on this particular platform you can use tab, and that's good. And I think tab is either tab or 4 spaces, but I prefer to use tab, right? So I think you should too. Then after defining a record, and also you create your state. So the state code state to-do list. Okay, so the next thing when defining smart contract on Eternity to create a state. Now, what the state does is it monitors the flow of your smart contract. It's how you get to define the state of smart contract. So let's say you're going to you're going to change the value of some sort of smart contract. Use state to keep track of what you're going to modify. Then basically now in this to-do list application or smart contracts, we are going to monitor how many to-dos are being created and how many tasks are being created on the smart contract, and also the to-do content. So if you say I defined an index counter, we're going to, every time we create a new task on the smart contract, we'll increment the value of this. And the next one to-do list is going to create like a structure to store all the various tasks on the smart contract. Index counter equals to 0. To-do lists equals to this. Okay, so whenever you create a state on Eternity, you also have to initialize that state and give a default value for that state. Now, the index counter, which is basically how I'm going to give a default value of 0. This initial value to 0. I will put an empty object for our to-do list also. So there are some important things that you should also note when creating smart contract. Like these are keywords. You can't replace this with any other thing. This record, and also this state. And also this stateful. This stateful basically, well, entry points are like functions, basically like container, a group of a kind of like a module of codes where you store a lot of codes. So entry point basically mean, okay, that particular module is public and everyone can access, can have access to the module or function. And the stateful tells activity or tells the smart contract that, okay, this particular function or module should be updated. Now, so after all this, the actions we want to create on this smart contract, I want you to create tags. Tags. We want to be able to read the tags. We also want to be able to complete the tags. I don't know if my screen is still showing. Okay. Yeah. Okay. Yeah, it is. It is. Okay. So we'll start with this. We're going to create a task or a to-do on the smart contract. And it's quite simple in Eternity. You just need this stateful keyword with this entry point, and also create the name of the function, which is let's say create tags, right? Then put this to do string. Okay, so in a way, you need kind of like basic knowledge of programming when designing smart contract, building a smart contract. So for those who have been programming for a long time, this will make sense. This whole thing is like a function, basically. And this is basically the name of the function. It's what we call arguments. So as we are creating this function, and after creating this function, when we are calling it, we're going to pass in this particular argument here and give this particular argument. So we can't call this function without this argument. Okay, argument to do is empty. If this particular to do is empty, we want to, no, if it's not empty, we want to do some certain tasks. We want to create an index, get our index counter, or I created here. This is basically the index counter. I want to call this, I want to also increment it. So remember earlier I said that, okay, when we are creating a new tag, we're going to increment that particular variable. That's what I'm trying to do here. And also I'm going to create a new tag with this. So I'll come here, basically, say, okay, what did I define here? Then make it easier for me. And I'll paste this here. Now, our ID, this is a new tag on the smart contract. We're going to give this value. This should be 1. So we'll just call this value index here, copy this here, and okay, and this to do, I'll give it the value of this argument here. Change this to equals to, put this here, and this creator. Well, in Sophia you can. Well, this creator basically means your wallet address. That's basically it. These addresses, and we can use a default function in Sophia called call.caller. This will get the wallet or the person address who call this function. And to get tags was saved on the blockchain, we can use another function Authentic provide called chain.timestamp. And we'll set this completed to false. Okay. I'm going to remove this here. Okay. So let me go over everything again. So this is a record. This record basically means kind of a model of what we are trying to achieve, of what what we want to save on the Authentic blockchain. So we have this ID, which is basically the particular index of that task. So we have this to do, which is basically the task, the content of the task. We have this creator, the person who created the task, and we have this created. This basically means the timestamp or the particular time this particular task was created on the blockchain, and this completed who completed field basically means the particular, whether this particular task has been completed or not. So it's going to keep track of whatever we want to modify as our smart contract keeps executing. And this is basically initializing the state when the smart contract is being run for the first time. Then we have this particular function which basically creates a to-do on the blockchain. So I said this is basically a function. This stateful basically means that, okay, this function will be modified as this smart contract is running. And this entry point basically means that, okay, this is publicly available for everybody to call. And this is basically the name of the function. This is an argument. So as we are calling this particular function, we're going to pass this here. Now, this is it's a little logic. So we're going to check if the was 0 to 1. Then as we are doing this, we are going to modify the state, this particular state. We use the put keyword on Sophia. We'll call the state, pass this to the list here.
Goodness, sorry, we can't see the screen again.
Wow. Okay. I don't know why, but anytime I leave this particular tab, it just goes off. Okay. So go back here. This is going to let us modify the state of a smart contract. To do lists. Yes. This is it. Index. Okay. Say I'm having a sync. Am I having this error? Okay. Let's see if I can refresh my tab. Okay. Okay, good. So we don't have that error again. So so the good thing about this AEStudio is that as you are building your smart contract, you can be testing, okay, what you have been doing so far. So I can go ahead and deploy this smart contract on the Authentic blockchain. Right now, I'm not deploying it on the testnet. I mean on the mainnet. I'm going to deploy it on the testnet. So what testnet or mainnet simply means that, okay, to get started with the Authentic blockchain or any blockchain platform, they usually they give you a testnet to, like, try just to get started with that, to see how it works. So it's kind of like an alternative to the mainnet. But the testnet, this time you don't get to spend real money on real cryptocurrency. They're basically fake. So if you come here, you'll see this 5 AE, 9.9 AE, 9.98, 9.99. These are not real AE coins. They don't really have any monetary value. They're just basically for you to like see how the Authentic blockchain ecosystem works. Cash this 5E doesn't really deploy this. What's okay, good. So I'm going to wait for this to work. Can you guys see my screen? Yeah.
Yeah, we can see your screen.
Okay. Okay, cool. So yeah, this. So that's why I love using this particular web-based platform, that you can really test out your ideas or do. So
Hello, Goodness, are you still with us? Okay. I think we lost Goodness there. We're so sorry for the break in transmission. I think he's having a lot of network issues, but I do hope that we learned a few things from him. And when he comes back, we have a few questions here for him